Hi, welcome to the video on parametric and non-parametric models. By the end of this video, you will be able to explain the difference between parametric and non-parametric models. So far, we have seen two predictive models, linear regression for regression problems and logistic regression for classification problems. Now in this video, we will be looking at the decision tree algorithm which can handle both the regression and classification problems. But before we dive deeper into the decision tree algorithm, let's first understand a small concept, that is function. We will begin by answering a question. What is machine learning all about? Well, we are almost halfway through the training now. We should be able to answer this. Machine learning can be explained in layman terms as learning a function f that maps input variables x to output variables y equal to fx, where x and y are independent and the dependent variables respectively. The mathematical form of the function is generally unknown, so our job as machine learning practitioners is to evaluate different machine learning algorithms and see which is better at approximating the underlying function. Different algorithms make different assumptions or biases about the form of the function and how it can be learned. For instance, we have worked with the linear models quite extensively in this training. Can you recollect any assumption in those models? You are right. In linear models, it is assumed that the relation between the input independent variable and the output dependent variable is linear in nature. If you do not remember that, I would recommend you to go back and have a quick revision of the module 5. Now that we are looking at the decision tree algorithm, which is entirely a different model, it is essential to know that unlike linear and logistic regression, decision tree algorithm do not have any restrictions or assumptions. To understand what this means, let's understand two broad categories of the predictive models, that is parametric predictive model and non-parametric predictive model. Let's start with the parametric models. Algorithms that make strong assumptions about the form of the mapping function are called parametric machine learning algorithms. By making strong assumptions, parametric models are very simple and interpretable. No matter how much data we are providing to the model, the set of parameters will never change. We cannot define it any better than the definition which is present in the book Artificial Intelligence, a Modern Approach. So, I will just quote that a learning model that summarizes data with a set of parameters of fixed size independent of the number of training examples is called a parametric model. No matter how much data you throw at a parametric model, it won't change its mind about how many parameters it needs. These kind of algorithms involve two steps. First, select a form for the function. Next, learn the coefficients for the function, that is, parameters for the function for the training data. An easy to understand functional form for the mapping function is a line as is used in linear regression. Y equal to x1m1 plus x2m2 plus x3m3 plus c, where m1, m2, m3 and c are the coefficients or parameters of the line that control the slope and the intercept, and x1, x2 and x3 are three input variables. And a number of these parameters would not change irrespective of the size of the data, that is, whether we have 1000 observations in our dataset or 1 million. The number of parameters that we would want to estimate would remain 4 only, that is m1, m2, m3 and c. Assuming the functional form of a line greatly simplifies the learning process. Now, all we need to do is estimate the coefficients of the line equation, and we have a predictive model for the problem. The problem is, in any given data, the actual unknown underlying relation or function may not be a linear function like a line. It could be almost a line and require some minor transformations of the input data to work, right? Or it could be nothing like a line, in which case the assumption is wrong and the approach will produce poor results. Linear regression and logistic regression fall under the parametric algorithms. But there are some benefits of the parametric algorithms. These methods are easier to understand and interpret results. They are very fast to learn from data. They do not require as much training data and can work well even if the fit to the data is not perfect. The major limitations of parametric algorithms are, by choosing a functional form, these methods are highly constrained to the specified form. The methods are more suited to simpler problems. In practice, the methods are unlikely to match the exact underlying mapping function. So, we can see that there is a clear trade-off. Using parametric algorithm introduces simplicity and interpretability, but at the cost of relatively poor modeling. Now, let's look at the other predictive model, that is non-parametric algorithms. Algorithms that do not make strong assumptions about the form of the mapping function are called non-parametric machine learning algorithms. By not making assumptions, they are free to learn any functional form from the data. Again, I will resort to the definition given in the book we just discussed, Artificial Intelligence, a Modern Approach. Non-parametric methods are good when you have a lot of data and no prior knowledge, and when you don't want to worry too much about choosing the right features. Or, in other words, when we are not concerned about the nature of the data or the relationship between the target or the independent variable. Non-parametric methods seek to best fit the training data in constructing the mapping function, whilst maintaining some ability to generalize to unseen data. As such, they are able to fit a large number of functional forms. An easy method to understand non-parametric model is the decision tree. The method does not assume anything about the form of the mapping function. Let's look at the key benefits of non-parametric machine learning algorithm. These algorithms are capable of fitting a large number of functional forms. There is no assumption or weak assumption about the underlying function. They can result in higher performance models for prediction. Now, let's look at the drawbacks of the non-parametric algorithms. These algorithms require a lot more training data to estimate the mapping function. Next, they are a lot slower to train as they have far more parameters to train. Further, there is more risk to overfit the training data, and it is harder to explain why specific predictions are made. We will be understanding the concept of overfitting later in this module. In this video, we have learned about parametric and non-parametric models. We have also learned that decision tree belongs to the non-parametric model, and thus in decision trees, we do not assume any set of parameters. In the next video, we would have a look on how the decision tree works.